This video we are going to solve the problem. Consider the linear transformation T on R3 defined by T of x, y, z equal to x plus 2y minus z, y plus z, x plus y minus 2z. Our aim is find a basis and dimensions of the image of T and the kernel of T. The first step I want to, so this is the given problem. Okay, so how we are going to approach this problem? First we consider, we know the well known result. So first I want to state the result. Let Rn and Rm be vector spaces with bases alpha and beta respectively, and let T is a linear transformation from Rn to Rm with matrix representation so T alpha to beta, I take as there is a matrix A, then kernel of T is nothing but null space of A. Similarly, image of T equal to column space of A. So my first aim is I want to find what is the A. Okay, so then only we can find kernel of T is nothing but a null space of A, and image of T is nothing a column space of A. We already know how to find the column space of A and null space of A. So whenever we are converting we require alpha and beta. So in this problem they didn't give what is the alpha and what is the beta. So our T is from R3 to R3 only, correct? So we want to use the standard basis as alpha and beta. The standard basis of R3 I will take an as E1, E2, E3. What is the E1 means? So we already know that E1 means 1, 0, 0. E2 means second component only 1, remaining part are 0. E3 means 0, 0, 1. I taken as alpha and beta are same. We make the linear transformation to matrix transformation, that is T of alpha to beta, that is T of E1 their coordinate vector in beta, T of E2 their coordinate vector in beta, and T of E3 coordinate vector of beta. So this is where only we have to find the linear transformation to matrix representation. So we already posted the detailed video how to compute it in my YouTube channel. If you want to see, I will give in the description link. Okay, what is the T of E1? T of E1 is, so this is my linear transform is x plus 2y minus 2z. So it's become 1, 0, 1. So now T of E1 coordinate vector in terms of beta is same thing only will come because of it's a standard basis only. Okay. So T of E2 we get as 2, 1, 1, and T of E2 beta is the same way only will come. So it is not always same, because in this case standard basis means automatically these things are will come same. This is not always same. Okay. T of E3 equal to minus 1, 1, minus 2. So T of E3 beta also same. Okay, that is minus 1, 1, minus 2. So my T of alpha beta is, so the column wise I want to represent, correct? That is T of E1 beta, T of E2 beta, T of E3 beta. That is 1, 0, 1 first column. Second column is 2, 1, 1, 1. And third column is minus 1, 1, minus 2. So I taken as this is the matrix A, I will take it. Okay. Now the image of T is column space of C of column space of A. So how I can find the column space? Both the way you can do it. I will do in the traditional way. First I want to find the pivot position, row echelon form only I am going to use. Okay. So A equal to 1, 0, 1, 2, 1, 1, minus 1, 1, minus 2. Okay. So the first step I want to choose this guy as the pivot position. I will choose because the non-zero element is there. So directly I can choose. So this is equivalent to, so I kept first row is as it is 1, 2, minus 1. The second row is, first column is already 0. So I didn't disturb the second row. 0, 1, 1. So third term is, third row first column is not 0. So I want to make it as 0. So R3 is R3 minus R1. So there will happen, this guy is 0. This guy is 1 minus 2 is minus 1. Similarly, you will get it as here minus 2 plus 1 is again minus 1 will come. So now this is the first pivot position. My second pivot position is, this is the 1. Okay. So then I kept it, first row is as it is 1, 2, minus 1, 0, 1, 1. Third row is I want to, this guy is I want to make to 0, correct? that is third row, second column I want to make it 0. So R2 is, sorry, R3 becomes R3 plus R2. So this means the first element 0 plus 0, 0, minus 1 plus 1 is 0, minus 1 plus 1 is again, you will get the 0. So the pivot positions are these two guys only. Correct? So whenever the pivot position will come, their corresponding columns are the column space. Correct? So then this guy is the column C1, C2 is the column space. So column space of A is the first column C1 1 0 1 and the second column is 2 1 1. So this implies, because my question is find the basis of image of T. The basis of image of T is nothing but your C of A only, that is 1 0 1 2 1 1. So what is my next step is I want to find the, so the first is I completed find the image space of T, basis of image space of T I find it. My next step is I want to find the kernel of T. Kernel of T means nothing, that is null space of A. So null space means I want to find, so we already know that n of A equal to n of U. So U is the row echelon form. Okay. So that U equal to here is, U is 1 2 minus 1 0 1 1 0 0 0. This is my U. So the null space of U is U of X equal to 0. So we want to find what is the X. So 1 2 minus 1 0 1 1 0 0 0 times I multiply by, input is the 3 components, that is x1, x2, x3. You can choose x plus x, y, z, both the way you can use it. Okay. So 0 0 0. Now from this equation implies, that is x1 plus 2 x2 minus x3 equal to 0, x2 plus x3 equal to 0. So here free variables are, x3 is the free variable, okay, because there is no pivot element for x3. The basic variables are x1 and x2. So that is also we want to write here, basic variables are x1, x2, the free variables, x3, because it does not have the pivot position there. So that's why, so you can represent this is as x1, x2, x3 as x3 is same with x3 only, correct? x2 is minus x3 and x1 is 2 times minus x3, so 3 3 x3 will come. Correct? Because this step is from this equation I will get this one, because x2 is minus x3. So minus 2x3 minus x3 is minus 3x3. So x1 is minus 3x3. So this implies x1, x2, x3 as x3 times 3 minus 1, 1. This is the null space, correct? So basis of null space is, this is the basis of null space. This guy is the basis of null space. Here x3 is any constant, any scalar from the field. So basis of so this implies from our result kernel of T, basis of kernel of T. Okay, so we found the basis of kernel of T also. Okay, if you want to how to find the null space, column space, we already posted a video. I will in the description link. Okay, I hope you understand how to find the basis of image of T and kernel of T. Thank you for watching this video.